Education Society, redefining excellence.
Hello ma'am, my name is Omkar Venkatrao Baswekar. I am studying in third year electrical engineering in ZIL Polytechnic Nare. My group members for micro project are Mote Lakshman Balasaheb, Ikke Jalindar Shivaji, Zamre Rishikesh Vijay, Baswekar Omkar Venkatrao. Our group micro project title is Application of LED lamp. In the LEDs are promising light source whose efficiency was 10 times greater than the incandescent lightning. Long operating life and reliability has made LEDs as a potential choice for next generation lighting system, including automotive emergency backlight, indoor and outdoor. LED lighting can be referred to as solid state lighting because an LED is solid state technology. LEDs were first developed in 1960s and its character decides this light source is suitable for indication, not illumination. Indication. In an indication, first is indication 2 refers to use of light source to view directly to self-luminous object. Example, signs, signals, indicators, lights in electronic equipment. Illumination. In illumination 2 refers to use of light source to view other object by the light reflected from those object. Example, lightning found in rooms and task lighting in desk. What is light emitting diode? The light emitting diode is a PN junction diode. It is specially doped diode and made up of special type of semiconductors. When the light emits in the forward bias, then it is called as light emitting diode. Below is a diagram of light emitting diode. This symbol of light emitting diode. The LED symbol is similar to the diode symbol except for small arrows that specify the emission of light. Thus, it is called light emitting diode. The LED includes two terminals, namely anode and the cathode. Below is a symbol of LED. Working principle of LED. The working principle of the light emitting diode is based on the quantum theory. The quantum theory says that when the electrons comes down from the higher energy level to the lower energy level, then the energy emits from the photon. The photon energy is equal to the energy gap between these two energy levels. If the PN junction diode is in the forward bias, then the current flows through the diode. The flow of current in the semiconductors is caused by the flow of holes in the opposite direction of current and the flow of electrons in the direction of the current. Hence, there will be recombination due to the flow of charge carriers. The recombination indicates that the electrons in the conduction band jump down to the valence band. When the electrons jumps from one band to another band, the electron will emit the electromagnetic energy in the form of photons, and the photon energy is equal to the forbidden energy gap. For example, let us consider quantum theory. The energy of photon is the product of the both Planck constant and frequency of electromagnetic radiation. The mathematical equation is shown where is known as Planck constant and velocity of electromagnetic radiation is equal to the speed of light, that is the frequency radiation is related to the velocity of as in the frequency is denoted as a wavelength of electromagnetic radiation, and the above equation will become as a from the above equation we can say that the wavelength of electromagnetic radiation is inversely proportional to the forbidden gap. In the general silicon germanium semiconductors, this forbidden energy gap is electromagnetic wave during recombination is in the form of infrared radiation. We can't see the wavelength of infrared because they are out of our visible range. Construction of LEDs. The construction of LED is very simple because it is designed through the deposition of three semiconductor material layer over a subtracted. These three layers are arranged one by one where the top region is p-type region, the middle region is active, and finally the bottom region is n-type. The three regions of semiconductors can be observed in the construction. In the construction, p-type region includes the holes and the n-type region includes the electron, whereas active region includes both holes and electrons. When the voltage is not applied to the LED, then there is no flow of electrons and holes, so they are stable. Once the voltage is applied, then the LED will forward bias, so the electrons in the N region and holes from P region will move the active region. This region is also known as depletion region because the charge carriers like holes includes a positive charge, whereas electrons has a negative charge, so the light can be generated through the recombination of polarity charge. Here is some diagram of LEDs. IV characteristics of LEDs. There are different types of LEDs are available in the market. There are different LED characteristics which includes the color, light or wavelength, radiation, light intensity. The important characteristics of LED is a color. In the starting use of LED, there is only red color. As the use of LEDs increased with the help of semiconductor process and doing the research on the new metals for LED, the different colors were formed. The following graph shows the approximate curves between the forward voltage and the current. Each curve in the graph indicates a different color. Here is a graph. Types of LEDs. There are different types of LEDs present and some of the are mentioned below. Gallium arsenide LED, gallium arsenide phosphide LED. It is colored in red to infrared or orange. Aluminum gallium arsenide phosphate. This is high brightness red, orange, red, and orange and yellow. Gallium phosphide in color red, yellow and green. Aluminium gallium phosphide, it is color in green. Gallium nitride in color green. Gallium indium nitride, it is colored in bluish green and blue. Silicon carbide, it is colored in blue as a substrate. Zinc selenide, it is colored in blue. Aluminum gallium nitride, it is colored in ultraviolet. It is the whole information about the light emitting diode. We studied about the whole information and characteristics, working, construction about the LEDs. Thank you.
Zeal Education Society, redefining excellence.